And good morning, fourth grade students of room 502, our room. Welcome to Eureka Math. I think by now we know what Eureka Math, a Latin phrase, means in the English language. It means I have found it. And what have we found? Well, boys and girls, ladies and gentlemen, damas y caballeros, we have found the best way to learn math, which is better than gold. All right, we're going to start right off with a little bit of homework review. Let me clean my place here. All right, there we go. So take out your homework from last night. And let's see, it'll be lesson 14, right? We'll just do a couple of these and you can check your work. Excuse me. So let's see, everything's all lined up. Good. Let's take a look at problem 1A. And we had 9 minus 2 is 7. And can't take 9 tenths away from 8 tenths, so we will grab an 8 there. Grab, 10 tenths. So that becomes 18. 18 minus 9 is 9. 8 minus 4 is 4. 1 minus 1 is 0. And 7 minus 2 is 5. And let's skip over to our letter F. 9 minus 0 is 9. 8 minus 7 is 1. 9 minus 0 is 9. 9 minus 1 is 8. 7 minus 2 is 5. And drop down the 8. And we're all set. And finally, let's take a look at H. 9 minus 2 is 7. I can't take 9 tenths away from 8 tenths, so I'm going to borrow 10 tenths from this 3 over here. That 8 will become an 18. 18 minus 9 is 9. I can't take away 4 hundredths from 2 hundredths, so I'm going to borrow 10 hundredths. That will become a 12, and that will become an 8. 12 minus 4 is 8. 8 minus 1 is 7. I can't take 9 10,000s away from 7 10,000s, so I'm going to borrow 10 10,000s. That'll be a 17. 17 minus 9 is 8. 1 minus 1 is 0. Put in my comma and we're all set. So go ahead and take your homework and put it in the old homework drawer. Pause the tape and we'll keep on moving on. Welcome back. You do not have this. Unfortunately, the copier is still broken, so you do not have this. What you do have is scratch paper. So I don't want you writing down the problem, just writing down the solutions, okay? So today we're going to use place value understanding to, I don't know how that 82 showed up, cross that all out, to any place value. So it's a lot. Using a standard subtraction algorithm to apply the algorithm to solve word problems using our favorite tape diagrams. The first thing we're going to do is the convert units. And you can do this on your scratch paper. We're going to count by 20 centimeters. So we'll say 20 centimeters, 40 centimeters, 60 centimeters, 80 centimeters, whoops, not 80 centimeters, and then we get to 1 meter, 100 centimeters. Then we can go to 120 centimeters, 140 centimeters, 160 centimeters, 180 centimeters, 2 meters. So 100 centimeters are in 1 meter. That's what we're trying to clarify here, to get into your head. Let's do a little conversion. We'll do 130 centimeters, remember this from yesterday, equals blank meters and blank centimeters. Well, think about it. We have 100 centimeters equals 1 meter, so I have 1 meter and 130 centimeters and 30 centimeters left over. We'll do one more, then we got to move on. We'll say 175 centimeters equals blank meters, blank centimeters. Well, once again, 100 centimeters equals 1 meter. We have 75 centimeters left over. All right, so now our application problem. Let's see what's going on here. When the amusement park opened, the number on the counter gate read 928,614. At the end of the day, the counter read 931,682. What we need to find out is how many people went through the gate that day, okay? So we're going to use, your favorite, the tape diagram. Here we go. What's our whole? Well, our whole is the number at the end of the day. 931,682. So we're going to say 931,682. And what are we taking away to figure out this out? We're taking away what the counter read at the beginning of the day, which was 928,614. So what we don't know is this right here. This is like the answer. That's what we need to find out. So let's deal with the standard algorithm. We're going to take the whole. All right, the whole, which is 931,682. And we'll subtract what the counter read the morning when the amusement park opened, which was 928,614. By subtracting, we can determine how many people showed up to the park that day. So there's our problem. If you're comfortable with this, do it. If not, follow along with me, Mr. Leggett. Okay, let's take a look at what we got going here. I can't take 4 ones away from 2 ones, right? So I'm going to have to borrow 110, and this will become a 12. 12 minus 4, that's 12, 11, 10, 9, 8. 7 minus 1 is 6. 6 minus 6 is 0. Oh, look over here. 8,000s take away from 1,000s? No, it can't be done. So we have to borrow from the 10,000s. This will become a 2, and this will become 11. Now 11 minus 8, 11, 10, 9, 8. 7, 6, 5, 4, 3, 3. Yeah, there we go. 11 minus 8 is 3. 2 minus 2 is 0. 9 minus 9 is 0. And that's our answer. So we read, remember we drew, and now we will write 3,068 people went through the gate that day. Assuming that people that weren't allowed to come back in to the amusement park, different people. All right, so let's keep going. We're going to go to our next page on our scratch paper. Scratchity, scratch, scratch, scratch paper. And Mr. Lake's got to find his scratch paper packet. There we go. Well, who knows? I'll use this right here. All right, we're going to continue on with subtraction. But this will be multiple times that we're decomposing. So let's go ahead and write this out up top, just like we did yesterday. 253,421 subtract 75,832. And now we will create our tape diagram. And this is, oops, I did it on the bottom. That's okay. Do a reverse tape diagram. 253,421. Okay, and what are we taking away? We're taking away 75,832. So that's what our tape diagram looks like. So now that we have this, we could do the standard algorithm. Go ahead and pause that if you need to copy that down. I'm going to move this up. I'm going to do this kind of large so we can really see. So it's 253,421 minus 75,832. And just by looking at this, every digit is larger, it looks like, on the number I'm subtracting. So there's going to be a lot of decomposing. So let's start off with decomposing our two tens to 110. All right? And this 1 would become 11 ones. 11 minus 2, 11, 10, 9. Looks like we can't do much with this. I can't take away 3 tens from 110. So I'll have to decompose this 100. And my 400 becomes 300s. And here's where some of us got mixed up the other day. When we crossed this out, we decided to make it smaller. It's going to stay a 1. So we're going to just cross it out and put an 11 up top. Okay? So 11 minus 3, 11, 10, 9, 8. Here I can't take away 800s from 300, so I'm going to borrow 10 hundreds from that thousands column. That will become a 2. And then we cross out the 3. It's going to stay a 3, but now it'll be 13. Okay? That didn't make much sense, but we don't need to lower it any further. It's 300ths, now it's 1300ths. 1300ths minus 800ths is 500ths. 5,000 minus 2,000 cannot be done. Simply cannot be done. So we'll have to borrow from the 10,000s. I'll take one 10,000. This becomes a 12. 12 minus 5 is 7. And come over here, I can't take away 7 10,000s from 4 10,000s, so I'm going to borrow 100,000 from here. Now I have 14 10,000s minus 7,000s. Well, I know that that would be 7, and then I just bring down the 1. So I have 177,589. Let's take a look at another problem. Go ahead and turn to a different page on your scratch. No, I brought a bunch of scratch paper over here. No, I can't find it. Okay, here we go. So, let's take a look. I'm going to double check my camera, make sure everything's going as planned. It is. Hooray. So let's start off with, we're not going to use the tape diagram on this one. We're just going to go straight forward. Oops, I'm going to give us a little more room. 200 with all this decomposing, we'll need it. 253,421, and we're subtracting 75,800. Wait a second. We already did this one, didn't we? Yeah, we're good. So sorry. Let's get another piece of scratch paper out. And this is the doozy. We are going to do a tape diagram here. 1,000 minus 528. Look at all those zeros. That can be a challenge, okay? So let's do our tape diagram. Our whole is an even 1,000. And we're taking away 528, a little more than half. What we don't know is the answer. Okay, so we got all that going on. Are you ready? Well, here we go. We're going to do a couple of different things here. We're going to do a place value chart. And let's get to that. We only need 4 columns, right? Thousands, hundreds, tens, ones. All right. So let's do ones, tens, hundreds, thousands. First thing we're going to show is our number, 1,000, okay? So we have 1,000 and 0 all the rest of the way. But we have to subtract 528. I'm going to set up my standard algorithm over here. Okay, see what we can get going. And let's go to the ones. I can't take away 8 ones from 0. Can't be done. So we have to start decomposing, all right? I'm going to take this 1,000. It's going goodbye. And this 1,000 is giving up 10 hundredths. Are 10 hundredths 1,000? You bet they are. All right? So I've said goodbye to this 1,000, and now we have 10 hundredths. But look, can't do that. Can't do that still, so I have to say goodbye to you, one of these, and it's going to go over to the tens column. Because 10 tens equal 100. Now I can cross this out, because it's 9 now. See how it's only 9 place value discs? And now this is 10. But I still have to deal with my ones over here. So I'm going to take 110 and give it to the ones. Now this, the tens, becomes a 9, and the ones becomes a 10. Now it looks like I'm ready to subtract. Isn't that marvelous? Yes, it's marvelous. So let's start subtracting. 10 minus 8. 1, 2, 3, 4, 5, 6, 7, 8. It looks like I have 2 left. Then we go to 9 minus 2, so I'm taking away 2. And I have 1, 2, 3, 4, 5, 6, 7. I really like this math. Then I'm taking away 5. 1, 2, 3, 4, 5. And I have 1, 2, 3, 4 left. So it looks like my answer is 472. And this one, you know what? I'm going to say, you know what? I better double check this. How are we going to double check this? Through addition. Did somebody say addition? Oh, well, look who made it here. It's Billy Bobcat. Yes, it is. And if it's one thing I love, it's addition. I like checking my subtraction with addition more than just about anything other than a juicy rabbit. Okay, well, let's not talk about your diet. Let's talk about addition. Are you ready for that? I'm always ready for addition. All right, well, then let's do it. We're going to say 528 plus 472. Well, Billy Bobcat, do you want to handle this? Well, sure, Mr. Leggett. I know you must be very tired. It's early in the morning. So I know that 8 plus 2 is 10. Don't forget the little 1 there. Okay, thank you. And then I know that 2 plus 7 happens to be one of my favorite numbers, 9. So 2 plus 7, 7 plus 2 is 9, and add the 1, we get 10. Don't forget that little guy right there. Okay, I won't. And now 5 plus 4 is 9, plus the 1 is an equal 10. Well, you really do love to add. Oh, yes, my whole family loves adding. Well, that's marvelous. What are you going to do the rest of the day? Oh, I might sleep, then wait till night, and then go hunting for rabbits. Okay, well, that sounds like a good plan. Be careful out there on a lot of traffic out there on the 371. Oh, I'm always very careful. Look left, look right, look left, make sure there's no cars coming. Well, thank you so much, Billy Bobcat. You've been a more than welcome guest, much better than the dictator. Oh, well, yes, he's a bit of a fool, isn't he? Yes, he is. I'll see you later. Bye now, Mr. Leggett. Such a wonderful little bobcat. Tells it like it is. All right, so we're going to continue on with problem 3 of our problem set. Oh no, problem 4. We're going to need a brand new piece of scratch paper, and believe you me, we're going to use all of the scratch paper. So let's get busy on this one. Please don't be alarmed. Thank goodness the calculating cat's not around. He probably wouldn't let me do this problem. It's one, well, let's go right for the tape diagram. We're not going to even show the problem. Oh boy. Oh boy. Are you ready? We're ready, Mr. Leggett. We're going to put 1 million. Ha ha ha. 1 million. And we're going to subtract 345,528. What we need to find out is this answer. It can't be done, Mr. Leggett. Oh yes, it can. You just have to have faith in your math skills. All right, so we got our tape diagram set up. We're taking away 345,528 from 1 million. What we don't know is this, because this plus this will equal, ding, 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 1 million. Let's continue on down here and set up the standard algorithm. And I'm going to make it nice and big so we can all see it. Yes. Look it's all up to the 1 million place value. When you get all these zeros, this is what you got to do. I'm not going to make a place value chart. We're just going to go for it. Here we go. This fellow becomes a 10. But see, I know I'm going to have to decompose all the way down the line. So that 10 will become a 9. This guy becomes a 10. I almost did it the old school way. This 10 becomes a 9. This 0 becomes a 10, or 10,000s. But he needs to help out the hundreds, so we'll say you're now 9,000s, and this column is 10 hundredths. But the 10s need help, so the 10s become 10 tens. Then we finally get to the ones column, and lucky ones column gets to stay at 10. A perfect 10. Now we're ready to subtract. All the digits are larger or greater than these digits. 10 minus 8, 2. 9 minus 2, 7. 9 minus 5, 4. I'm going slow again. 9 minus 5. That's kind of convenient. Same thing. 9 minus 5 is 4. 9 minus 5, another 4. Isn't that convenient? Oh, reverse. 9 minus 4. 9, 8, 7, 6, 5. And look, 9 minus 3, 6. There is our answer. Should we follow the advice of Billy Bobcat and add to check? Well, I think that's excellent advice. So what we'll do is we'll add these two numbers, and it should equal 1 million. And here we go. Is this going to equal 1 million? I don't see how. 2 plus 8 is 10. 7 plus 2 plus 1 is 10. 5 plus 4 plus 1 is 10. Oh, my comma there. 4 plus 5 plus 1 is 10. 5 plus 4 plus 1 is 10. And 6 plus 3 plus 1 is 10. And there's our 1 million. Remember, we do 3, it's called a period, 3-digit places, 3 place values, and so on. All right, ladies and gentlemen, boys and girls, damas y caballeros, we got one more problem to do before we head up. So, word problem. Yikes. Let's get another piece of scratch paper. Hopefully you got enough. If you don't, head on over to the scratch paper department and get yourself a new piece. So last year there were 620,073 people in attendance at a local parade. This year there were 456,795 people in attendance. What we need to find out is how many more people were in attendance last year? How many more? Subtraction. So I'm not going to, well, should I bother with a tape diagram? Oh, why not? Let's just see what we got going here. Last year, this is the last year tape diagram. Here it is. Last year, 620,073. This year, new tape diagram. This year we had, this must have been bad weather. Attendance was way down, boss. I put out flyers. We advertised the parade on the radio, had television commercials, internet commercials. Nothing happened. It was the weather. I'm going to blame the weather. The weather was why there are less people in attendance this year than last year. All right, so let's go over here. Still a pretty good sized crowd. And we'll say 620,073. A lot of zeros. You know what zeros signal? Decomposition. Decomposing. It's not just for breakfast anymore. Alrighty, here we go. So I can't take away 5 ones from 3 ones, so I'm going to borrow from the decompose from the 10s, and that 3 becomes 13. 13 minus 5, 13, 12, 11, 10, 9, 8. Stuck here, stuck here, stuck here. Goodness me, what in the world do I do? It looks like it's up to Mr. 10,000s to help out his friends the zeros. So he's going to become 1 10,000. The thousands column will become 10,000s, but we're not done yet because we need some help over here. So this is going to become 9,000s, and this will be, 10 hundredths. But we still have to help over here. So the 10 hundredths becomes 9 hundredths, and this 6 becomes 16, or 160, 16 tens. 16 minus 9, 7. 9 minus 7, 2. 9 minus 6 is 3. We're here, I can't take away 5 10,000s from 1 10,000s. We will decompose one of the 100,000s, and this becomes 11 10,000s. 11 10,000s minus 5 is 6. 500,000s minus 4 is 100,000. And there we have our answer, 163,278. At this time, I'll leave that up there. At this time, please get out your problem set booklet. It's time for the problem set. Are you ready for the problem set? I hope so. I'm not, but I hope you are. You know why I'm not ready for the problem set? Because I ripped out the page and now I can't find it. So I'm going to have to go to my stack of problem sets and get out a problem set. Problems, problems, problems. You got a problem, or what you gonna do? All right, here we go. Of course, it's missing the page I'm looking for. How could that even possibly be? How can that possibly be? All right, wonderful. page 49. That's what we're going to go to. And we'll go to page 49. And this is not my name. This is where you're going to go, page 49. Today's date, 09/13/19. Woo. Okay, let's do this. It says, use the standard subtraction algorithm to solve the problems below. Now, let's give it a shot. If you're comfortable, you could do this on your own. If you need assistance, a little unclear about the concept here, please follow along with me. We're only going to do this for a total of 10 minutes. See how far we can go. So if you get done with this side, flip it over. Okay, right away, time to decompose. And I'm not going to, go on about all the place value and all that. I think it's not time to decompose. Mr. Leggett, you've already messed up. 0 minus 0 is 0. So I'm going to cross that out. We still have a 6 there. This 6 becomes a 5, and this 6 becomes a 16. 16 minus 8 is 8. I can't take 6 from 5. This will become a 0. That's a 15. 15 minus 6 is 9. Stuck with 0. I can't take away the 1. Can't have any help there. This is going to become a 0, my 100,000s place. This will be a 10, right? But we're going to decompose, make that a 9, make that a 10. Wow, they gave us a tough one right from the get-go. So 10 minus 1 is 9. 9 minus 9 is 0. 0's there. Wait, excuse me. Let me make sure I got this right. It's hard to see this early in the morning. Yep, looks like I got it right. So it's 9,980. Let's go over to number B. I promise to do a better job on this one. 0 minus 0 is 0. I got it that time. I can't take away the 8 from the 6. This is going to become a 5, and this will be 16. 16 minus 8 is 8. I can't subtract 9 from 5. So that'll become 0, and this will become 15. 15 minus 9 is 6. I'm stuck over here. 100,000s becomes a 0. This becomes a 10. But I have to decompose, so this is going to become a 9, and this is going to become a 10. 10 minus 9, 10,000s minus 9,000s is 1,000. Bring down the 9, and I have 91,680. Over here. Let's see. I can't take 2 from 1. I'm going to decompose from the 10s, and that 1 becomes an 11. 11 minus 2, 11, 10, 9. 5 minus 0 is 5. Okay, I can't take away 7 hundredths from 500, so I'll have to borrow 10 hundredths from the thousands column, and this 5 will become a 15. 15 minus 7 is 8. Over here, I can't take 4,000s away from 1,000, so this will become 3 10,000s, and this becomes 11,000s. 11,000 minus 4,000 is 7. Can't take away the 4 10,000s from 3 10,000s, so this 2 will become a 1. I have 13. 13 minus 4 is 9, and bring down the 1. You know what? I think I'm going to get a lighter pen too, just so I can see what's going on a little clearer. Kind of hard to see these little numbers. Alrighty. I can't take 7 ones away from 1 1, so I'll borrow from the 10s. This becomes a 5, and this becomes an 11. 11 minus 7 is what? 11, 10, 9, 8, 6, 7. Wait. 11, 10, 9, 8, 7, 6, 5, 4. I can't subtract 8 tenths from 5 tenths, so I'll decompose from the hundredths column, and then this becomes 15 hundredths. 15 hundredths minus 8 hundredths is 7 hundredths. All right. And I got to decompose from this thousands. That becomes 1,000, and this is 14. 14 thousandths minus 9 thousandths, or I'm in the hundredths column. 14 hundredths minus 9 hundredths is 5. And here I go with this, the thousands. I can't take away 4,000 from 1,000. So this will become a 3, and this becomes 11. 11 minus 4, we've already done that one before, is 7. I can't subtract 7 10,000s from 3 10,000s. My 100,000s will decompose over here to the 10,000s. I have 13 10,000s minus 7 10,000s is 6 10,000s, and bring down the 1. 1, 2, 3. There we go. Not this again. the millions. Once you get the hang, once you've done a few of these, they become not simple, but a little easier to deal with. Look at all these zeros. I know I'm going to have to just decompose like a madman. So we'll just go 0. This will be 10. Then it becomes 9. This becomes 10. Then it becomes 9. This becomes 10. Then it becomes 9. This becomes, and please do it just like this. This becomes 10, then a 9. This becomes 10, then a 9. And this gets to stay 10. There's no place else to, oh, brother. Mr. Leggett, you weren't paying attention. I was not paying attention at all. Okay, you lucky kids. We're just going to delete that one right there. We have all these zeros. I didn't pay attention over here. 0 minus 0 is 0. 0 minus 0 is 0. It's telling you it's early in the morning. Now I need to start decomposing. So this will become a 10, then a 9, then a 10, then a 9, then a 10, then a 9, and finally right here we have the 10. 10 minus 5 is 5, 9 minus 2 is 7, 9 minus 9 is 0, 9 minus 5 is 4, and 1, 2, 3, there's our answer. Well, I feel kind of silly. Messed that one up so badly. Let's go on to G. I can't take 9 ones away from 8 ones, so I'm going to borrow 10 ones from the 5 there, and this becomes 18. 18 minus 9 is 9. And I can't take away 60 from 40, so we're going to borrow 10 tens. This will be